Thanks for coming, everybody. Today we're going to be talking about some of the advances in eye tracking technology. Quick show of hands, how many people here have heard of eye tracking before today? Pretty much everybody. Okay, great. And how many of you have actually used eye tracking in a research study? Excellent, pretty good amount. So yeah, as Marjorie mentioned, we're talking about a technology that is no longer new. It's been around for about 100 years, but what is new, what is sort of something that's developed over the past 5 years or so, is the ability for us to take this research technology out of the lab and move it into the real world and capture some real insights about real behavior in real contexts. Before we get into the particulars of how eye tracking is being used these days, let's start with sort of a core question here. Why study visual attention? What is it about the eyes that make it useful for us to put on these crazy eye tracking glasses, record every fixation and movement of the eyes at 100 observations every second? What are we actually getting out of this? And to understand this, what you really need to think about is the fact that our experience as humans is a heavily visual experience. A lot of what our brain is doing throughout the day is making sense of and processing visual information. And therefore, by looking at eye tracking data, we're getting a very in-depth look at what's happening in your mind. What are you paying attention to? What are you interested in? What are the kinds of things that you ignore or overlook, or the things that don't engage you? The only way to really objectively learn about this is to actually look at that attention data in great detail, which is what eye tracking allows. However, there is a challenge. As Marjorie mentioned, in the early days of eye tracking, we had this sort of disconnect between real life, Exhibit A here on the video, somebody riding a motorcycle, and how real life was simulated in an eye tracking lab. As you can see, you're not exactly approximating the real experience of riding a motorcycle by sitting somebody on this silly bike in front of a screen and using an eye tracker to collect attention data. It's just not very realistic. So in the early days of eye tracking, we were sort of doing this balancing act between how can we collect accurate data, but at the same time make it as realistic an experience as possible. And this is something that we've made some major strides on just in the past 5 years or so. I'll go through a couple of the ways that eye tracking has changed recently that many of you may not be aware of and where that's taken us to today. First off, miniaturization of camera and processing technology. If any of you conducted an eye tracking study 10 or 15 years ago, you probably remember this big, heavy brick of technology that you sat in front of your monitor, and that's what you needed to conduct an eye tracking study connected to a big desktop computer. It was clunky, it was cumbersome. It's come such a long way now. Right now, the cameras themselves can fit onto the end of a pencil, and the processing unit is no bigger than your smartphone. Faster, stronger, more efficient software platforms. Obviously, this is something that's changed across the world in just about every industry. Eye tracking is no different. We've sort of leveraged updates in computer technology to take eye tracking out of the lab and bring it into the real world. Another big one is cloud-based data collection and processing. I remember a day where you would actually collect eye tracking data and put the data into an envelope and take it to a place called a post office and mail that data to your analysis team. And they would write a report and burn that report to something called a DVD and take it back to a mailman and send it on to the client. Obviously, not super efficient. Changes in cloud-based processing and data management and sharing have really taken it to the next level. The other piece, which I'll talk about a little bit, is for the first time, we're able to get into people's homes and collect eye tracking data on large-scale panels of people using just their webcam. So this technology that used to be you were anchored to a lab is now moving into homes. We'll talk about that as we move along here. And the number four element here in improving eye tracking and taking it out of the lab is all of the great people that are working on it. For years now, people have recognized the potential of eye tracking technology, and universities and research companies and usability companies have been looking at how can we take this powerful data source and turn it into something that's a little more applicable to how we work in the real world. So here we are now in this brave new world of eye tracking research. And I'll go through some of the applications, a few really quick examples of how we've used eye tracking technology, and hopefully inspire you guys to think more about how you might apply eye tracking to your own research. So we'll go through 5 of them. Number 1, attention on devices. Obviously, this is a big thing these days. You all have a smartphone. It's probably in your pocket right now. You're probably itching to take a look at it as soon as we hit the break. This is something that is, of course, very important to us in the research world, understanding visual behavior as it pertains to devices. And what we can do with new technology is we can test these in the wild. We don't have to do these tests in a usability lab. We can send the eye tracker home with participants, have them eye track themselves as they're watching television and using their phones and using their computers. We can look at second screen applications and other multi-device scenarios. And this has really become a powerful and popular data stream for our team, and many of our clients are quite interested in it. An example of some of the work we've done, we took a look at television commercials today. Obviously, there's been a bit of an erosion in attention to TV commercials. Our client wanted to understand what does that look like in a real situation. So we're able to test consumers in their homes using these eye tracking glasses, and we can show, okay, so while the television show is on, 80% of their attention is focused on the screen. But as soon as that commercial break starts, it falls off a cliff. You see the attention to the screen drop to about 40%. It's kind of occurring in these 2 to 3 second chunks. The advertiser's message is sort of lost in the shuffle. So what eye tracking allows us to do is not only look at what's really happening, but look at what's actually working, which commercials are engaging people. At what points do people look up from Facebook to see what's going on the television? And obviously this is very powerful for advertisers. Number 2, attention in the home. So as we've talked about, as I've mentioned, eye tracking has traditionally been something that takes place in laboratory settings, in grocery stores, and it still is. This is still a big part of what we do. But now with sort of updates in technology and eye tracking algorithms, we're able to test large-scale attention panels of people using their webcams as sort of a rudimentary type of eye tracker. This is great for basic types of ad testing, video testing, pack testing. The major benefit is lower cost and quicker turnaround. You're able to get results quite quickly. An example of how we've used this, we ran a study on soda packaging, looking at traditional packaging versus packaging that's sort of embellished with additional imagery. For example, you're all probably familiar with the polar bear on the Coca-Cola packaging. And what we found was not only is attention to these packages highly correlated with likelihood of purchase, but adding these additional imagery elements increases that attention. It pulls people in deeper and further increases the likelihood of purchase. So this is sort of an example of the type of pure attention study you might run with a large panel of people using their webcams. Of course, if you're doing something with shopper behavior in store, or reading a magazine in the waiting room, or usability in the workplace, you're going to want to use the high fidelity eye tracker, but this webcam-based tracking is a nice new technology for simple types of studies. Number 3, attention in the workplace. So this is something that there's always been a recognition that this was a big area that eye tracking had potential. Understanding how people interact with their work environment. The limitation has been how are you going to do this in a realistic way without changing the way that they actually interact with the work, without degrading the quality of the work they're doing, without distracting them? These days, it's easy. The eye tracking glasses that we use in our research make it possible to unobtrusively test people in real scenarios doing real work. An example of how we've used this, we worked with an automotive company who was interested in taking a position that used to take 6 weeks to train somebody how to do and turn that into a 4-week process. The methodology they settled on was, hey, let's take our new recruits, let's show them footage of eye tracking data from an expert and use that as a way of training them what they should be looking at, what they should be paying attention to, what sort of things they can ignore. So on the training side, you have this aspect, and then on the evaluation side, you have this novice who's been learning for 4 weeks. You can look at his eye tracking data and ensure that he is completing the task in a visually efficient manner and noticing all of the things he needs to notice to do his job appropriately. 2 more here. I'll run through these pretty quick. We're up against the end of the time. Virtual reality, obviously virtual reality is all the rage these days. It's no different in eye tracking. We're able to integrate eye tracking systems directly into virtual reality headsets and track where people look in virtual spaces. An example of a study we're working on in this area with a hotel company. They're redesigning their lobby and they're interested in knowing, is this new redesign going to let everybody know where the check-in is, where the elevators are they going to be able to find everything they need to find? Obviously, you don't want to build the whole lobby and then figure out that there's a huge visibility gap. So you can build it in VR, you can test people in a virtual reality simulation study and assess attention within the new environment. And finally, we've got VR. Let's not forget about AR, actual reality. This is sort of a catch-all category. The bottom line is today's eye tracking, you're able to test pretty much anything, pretty much anywhere, at pretty much any time. A lot of the limitations that we saw in the past have just been disappearing at an incredible rate, and it's a very exciting time to be in this industry. One last example I'll leave you with. I'll make fun of millennials a little bit again, since that seems to be what we're doing here. We did a study, we did a study on attention in an automotive showroom looking at millennials versus older shoppers. How do you sell a car to a millennial? And what we found was they're looking at the same elements within the environment. They're both heavily focused on the dashboard and the interactive screens and sort of the exterior side of the car. But millennials are making these snap decisions. They're not taking nearly as much time to explore the content, read the messaging, and understand everything they can about the cars. So the message for automotive industry is you need to be quick with your messaging. You can't have large paragraphs of text. Everything needs to be snappy and to the point in order to engage this new audience of shoppers.